Welcome. This is an introduction to information theory. We will be covering bits, entropy, and compression. Get ready to dive into the core concepts of how information is measured, quantified, and efficiently stored. Meet Claude Shannon, an American mathematician, electrical engineer, and cryptographer. He is widely regarded as the father of information theory and a key figure in the digital revolution. His groundbreaking work laid the foundation for how we understand and manage information today. Information theory is the mathematical study of information, storage, transmission, and processing. It focuses on quantifying information content and determining the efficiency of communication systems. It provides the fundamental limits on how reliably we can communicate data. Let's talk about the bit. A bit, short for binary digit, is the fundamental unit of information. It can be either a 0 or a 1, representing two possible states. Think of it as yes or no, on or off. Everything in computing and digital communication is ultimately built upon these simple units. Now let's look at how to measure information content. The information content, denoted as I, is calculated as the base 2 logarithm of 1 divided by p, where p is the probability of an event. The key idea here is that rare events carry more information than common events. The rarer the event, the more informative it is when it occurs. Entropy is the measure of uncertainty or randomness in information. The formula for entropy, denoted as H, is negative of summation of p of x multiplied by log base 2 of p of x. Higher entropy means more unpredictability and, therefore, more information. A high entropy source is more surprising and thus conveys more information. Let's consider the example of a fair coin flip to understand entropy better. A fair coin has a 0.5 probability of landing heads and a 0.5 probability of landing tails. Using the entropy formula, H equals negative of open parenthesis 0.5 times log base 2 of 0.5 plus 0.5 times log base 2 of 0.5 close parenthesis, which simplifies to 1 bit. This means a fair coin flip gives us 1 bit of information because the outcome is equally uncertain. Data compression involves reducing data size by eliminating redundancy. It uses patterns and statistical properties of data to achieve this. Shannon's theorem states that optimal compression approaches the entropy limit, meaning we can compress data down to a size that reflects its inherent information content. Let's see an example of data compression technique. Huffman coding is used for efficient encoding of data. Consider the following character frequencies. A occurs 45% of the time, B occurs 13% of the time, C occurs 12%, D 16%, E 9%, and F 5%. Huffman coding assigns shorter codes to more frequent characters. The resulting Huffman codes are as follows. A is encoded as 0, B as 101, C as 100, D as 111, E as 1101, and F as 1100. Information theory has wide-ranging applications across various fields. In communication, it's used in internet protocols, wireless networks, and error correction. In data storage, it's used for file compression in formats like zip, JPEG, and MP3, as well as database optimization. It is also used in machine learning for feature selection, neural networks, and pattern recognition. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.